Hey guys, welcome to the final NFR playlist video. So today we would be discussing on the remaining NFRs, that is non-functional requirements, which is usability, testability, portability, interoperability, logging and auditability. Before this, I have recorded 5 important NFRs. There is a dedicated video for each one of them. Please do watch them. So starting with usability. So what is usability? So in usability, you have to focus on two things: UI, UX, user interface and user experience. Now, it doesn't matter you are at which level of a system designing. The important thing is, let's say if you are a principal software engineer or higher above that, you should not only think about the backend system, but you should think about the complete system end to end, where the user interface and user experience is again like a prime importance. What all things should be considered in user interface? In a user interface, think from a user perspective. The user is interacting with your backend system, with your system, using that UI that you are going to provide him. The first and very most important thing is like what problem I am trying to solve. Like what, let's say if it is a ticket booking system, I am allowing the customer to book the tickets. If it is a stock market system, I am allowing the customer to buy or sell the stocks. So that is the prime important thing. There can be n number of different features on the UI, but that is the major important thing. And the prime important is customer should be able to use that feature easily. It should be visible, like the buy sell button or the book ticket button. It should be easily visible. It should not be hidden here and there. That is the first important thing. Second thing, it should not be jittery. Third thing, the naming conventions, the names, the placeholders, the descriptions, everything should be clear in the normal language which a customer should be easily able to understand. That is again very much important. Customer should be able to use your system without any help, without any assistance. Then the fourth and final thing is proper and clear message. Let's say there is an order processing system. A customer is trying to place an order. Now that order can be successful, order can be failed. Whatever happens, doesn't matter. Customer should be able to get a clear message stating like, hey, your order has been successful, and at this time we would be delivering your order. Hey, your order has been failed because of so and so reason. Hey, your order is in process and we'll get back to you. We'll send you the notification. Whatever is there, give customer clear message. That is again like a very important part of a UI. Then comes the UX, that is user experience. A customer is interacting with your backend, so a major role of backend is also there. How your backend responds to the request from the front end, that enhances the customer experience. For example, quick response. So you see low latency, high throughput. That is the part of a performance NFR that we have discussed in one of our previous videos. The faster the response that you are going to give to the customer, the low the latency, the low the response time, the better it would be the experience to the customer. That is very much important. Second thing, reliable response. Whenever a customer is giving you the same request, give him the same response. It should not happen like today you are giving him the response, tomorrow not. Again, like in my reliability NFR, you would get more insights about how reliability should be achieved. So if it is failing, fail fast. So let's say if I am giving a request and let's say there is a payment service and payment service is interacting with the gateway. I know like my payment service knows like my gateway is taking more time. Then why every time I should accept the request from the customer and wait and then send the request to the gateway when I am going to know gateway is going to throw me an error. I can apply circuit breaker pattern. And immediately as soon as I am getting a request, I can send the customer, hey, sorry, we can't process your request because my gateway is on or whatever suitable reason is. But fail fast. If you are failing, fail fast. Then no infinite waiting. There is an HTTP connection that is established. Customer is sending a request. You are having multiple layers. You are interacting with multiple different services. If some of your services taking time, break the connection. Tell to the customer like, hey, your request can't be processed. There is some technical glitch. There is some internal process error. There is some server down. Whatever is happening, break the connection. Send the response. Don't wait customer infinitely. Assume you are a user and you are waiting on some platform for 1 minute or 2 minutes. Will that be a good user experience? No. That is again very much important. Second, timely notifications. Order has been set up, like order has been accepted, order has been shipped, order has been processed, order has been dispatched, order has been delivered. All these timely notifications without bothering to the customer to come to your platform every time and see the status. Give him the timely notifications. If a customer is aware about the life cycle of his order, he is satisfied without even coming to your platform again and again. This is a good user experience. Then we would be discussing on testability. There are different test levels that we know. I am not just going to enhance or elaborate on every single test level, but this is prime importance and 90-95% of the companies are not doing that. First is unit testing. We are testing an independent modules. You can apply TDD, BDD, test driven development, behavioral driven development, but unit testing is very much important. It tests every single function, every single corner cases, so at runtime there is very less chance of its failure. Minimum 95% code coverage is mandatory, should be mandatory in every of the company. Then integration testing. Testing not only single component but testing end-to-end flow. Important. Then load and stress testing. How much load your system can take. Very much important. If you do not have that figure, if sudden there is a spike, you haven't configured, there is no upscaling, downscaling policy, you haven't warm up your system, sudden spike can bring down your whole system. Bad user experience, bad reputation for the company. So better do load and stress testing. Based on that, configure your pods, configure your servers. Then Performance testing. Performance testing helps you to tell like what is going to be the latency, what is going to be the throughput, what is going to be the response time. Performance testing is important, based on which you can finalize the SLOs with your customers. Again, like in my SLA, SLO, SLI videos, I have in detail explained what is the performance metrics, how should we track that. Then comes chaos testing. Chaos testing, again, I have explained in one of my shorts. Chaos testing, whatever things are going to go wrong can go wrong in production server, you are trying to replicate that in your testing environment, so that like you are ensuring like, okay, something abruptly goes wrong in the production systems, how my system is going to react. Automation test suite, very much important. Automation test suite, any automation test engineer can write, or you can write it in the Postman also. Every time, as and when your application is going to go large, go long, more and more features you are going to add, every time you need to do the regression testing. Why? Because you have to ensure like there is no regression that is left. Every time you can't run the whole features one by one manually. Best you have an automation test suite. Every night you can just run the automation test suite, or after every feature completion, before merging that in the master, just run that test suite to ensure there is no regression left. And the very much final important thing is like every single component should be in isolation, should be testable. Next, we would be discussing on portability. Now, portability means what? Portability means like, okay, when I am designing my system, I am designing my system in such a way like I should be able to port my system from one entity to another entity easily and quickly. Now, what is the definition of entity? Let's take an example. For example, cloud provider. I do not want to be vendor locked. So let's say cloud provider, today my application is deployed on GCP. Tomorrow I should be able to deploy my application easily on AWS or Azure. By this, what does I mean? Like, write your system, write your code in such a way like rather than relying too much on any external cloud providers, you are writing your system in such a way like today if there is a requirement to leave one cloud provider and switch to another because of financial issues, like cost cutting issues, cost concerning, or more services, or whatever it is, you should be able to switch it easily. That is very much important. Try to use as much open source as possible, as much third party as possible, rather than sticking to one single cloud provider. For example, if you want to have an event driven mechanism, rather than using SQS, SNS of AWS, you can maybe use Kafka, you can maybe use RabbitMQ. So in this way, you should be able to switch your system easily rather than heavily relying on that particular cloud providers. Again, like hardware architecture, today you are on x86, tomorrow you should be able to switch to ARM or any different hardware architecture. Environment, today you have deployed on EC2 instances, tomorrow you should be able to move directly to the K8, like you should be having the Docker file, Docker compose file. Today, earlier, like people used to deploy directly a jar file, then they came the Docker, like where the image is created and the image is directly deployed. So your system should be in such format like you should be able to easily deploy from one environment to another environment. OS, today you are using, let's say, Linux, tomorrow you want to switch to Windows. I know like most of the production servers are there in the Linux only, but what I want to tell you is like the important part is you should be able to switch from one entity to another entity without making too much hassle. I am not saying like language, not everything is possible. Let's say you have written and your application is complete and all the features now you have written in, let's say, in Java, and tomorrow you are saying like, hey, I want to switch the language and I want to use Golang or something like that. That is not possible, because now that is like rewriting of an whole application. So not everything is possible, but when you are designing other than language or some other aspect, you should be able to decide and design like as much portability you can put it in your system as much possible. You should do that, so that like tomorrow, as and when your application grows, if the need arises, you should be able to switch one entity to another entity easily without too much hassle, too much rewriting of a code, or too much blockage, or too much downtime of your system. Database, today you are using Oracle, tomorrow you should be able to switch to MySQL, Postgres, or if you are using Cassandra, you should be able to switch MongoDB or any other NoSQL databases. Again, platform, today you are using on-prem, but you see like, okay, managing the applications are becoming difficult on-prem, you want to switch to cloud, you should be able to switch to the cloud. Again, like this is what portability means. Next, we would be discussing on interoperability. Means like, okay, my system is there, my system is interacting with multiple different systems. So I should be able, like with my one single code base, I should be able to interact with all the different systems. If tomorrow one system is going out, I should be able to interact, like easily plug and play another systems. For example, payment system. I am a payment system. I have different vendors or different tenants. Let's say one tenant is saying, hey, I want to go with PayPal. Another is saying, hey, I want to go with Stripe. Third is saying, I want to go with Braintree. There are like multiple different payment gateway. Mine is a single system. Different vendors are interacting with me. I should be able to navigate to a proper payment gateway with one single code base. It should not happen like for PayPal, I am writing a separate code base. For Stripe, I am writing a separate code base. No. So that's important to like go with an adapter pattern. There should be an adapter layer. That adapter layer is interacting with multiple different gateways. And now there is your main source code. There is an adapter and there is multiple different gateways. So the request response that is handling with the different gateways that is present in your adapter layer, but your original source code is just aware of and interacting with your adapter. It doesn't care like which gateway you are interacting with, and it is the job of an adapter to switch and to give the response in the proper format which the source code understand, because it knows like your source code doesn't care which gateway is interacting. And the benefit is like tomorrow you want to switch to any other gateway, you should be able to do that easily. Again, like for an example controller, there is one single controller, say Arduino Uno or Raspberry Pi. These are the different controllers. There are different IoT devices, there can be sensors, there can be input output devices, there can be multiple IoT devices. Now one single controller should be able to interact and communicate with multiple different IoT devices. It should not happen like, hey, if I want to use sensors, I need to place a different controller. If I am using this, I need to place a different controller. That should not happen. That is how interoperability means. Now, how to achieve interoperability? Try to use as much common and as much standard approaches, standard protocols as possible. For example, majority of the global standards are REST services, HTTP, OAuth authentication, HTTPS, TCP/IP, UDP. These are like a standard things that most of the vendors, most of the services, most of the systems are using. If you are building your system on that particular line, then tomorrow if any system is going out and any new system is coming, you should be able to serve multiple different systems, communicate with them with same base, with same code base, and you do not need to rewrite your whole application if you want to plug and play any new system. Then the final thing that we would be discussing on is logging and auditability. Logging, trace every single operation that a user means like your developer, your engineer, or DevOps engineer, whoever it is, he is performing any operation in your production servers. It can be database, it can be pods, it can be anything. Log that, so that like tomorrow if something happens, you are having a proof like, hey, this operation has been performed by this particular so and so user, so and so developer. Again, important thing is there should be multiple different versions. Most of the times I have seen is like you have one single API, tomorrow you want to deprecate or you want to add new features, you are directly overwriting that API. Don't do that. Come up with different versions. Then whenever you are deleting the data, don't directly go ahead and do a hard delete. Don't fire a delete command. Always go and do the soft delete. First, it enhances the performance. Second, you have the data preserved with you. You can use your data for longer term perspective, for analytics, for whatnot. Like that is very much important. Then appropriate and correct logging messages. Why? Because not tracing the flow. Let's say this is microservices environment, multiple microservices are there, order service, inventory service, payment service, and different services are there. Now in that case, tracing a request, like one request has been received by order service, it is flowing through all the services till the last service and then coming back. If any service goes down or there is a failure, you should be able to trace the whole order flow and not just like particular service. That's the reason like tracing is very much important. Again, the next thing is easy and quick debugging. By putting a proper log messages, whenever something is going to go wrong in the production, you should be able to directly go to the logs and directly pinpoint like, hey, what exactly has been going wrong. That is again very much important. And the third and final thing is security is important. You have seen that in my security NFR, like log messages, don't abruptly log any log statements like credentials or passwords or customer account balance or account number or this and that, like sensitive data. Encrypt and then log it. That is again very much important. It helps in enhancing the security. Plus, when you are logging, there can be such places like where a sensitive data is going to get logged. So log it separately. Don't log it with your normal data. Log it separately and persist it separately, because you know this is a sensitive data, and then keep it for the longer duration. If a normal log you are keeping it for 3 months, keep that log for maybe like 6 months or 1 year, so that like because this is a sensitive data, you should be able to come back and see, hey, what operation has happened 6 months or 1 year down the line. Then capture the DB change log, like DBGM is there based on which you can do CDC, like capture the database level changes. So capture that. Whenever you are adding or updating something, don't directly try to update that. Take a backup of it, like select, insert and then update, so that like, and this not necessarily all the information like user phone number is changing, you do not need to do that. But let's say if a transaction is their account balance is changing, in such cases you would not rather like to directly update it, but first take a backup and then update that. Again, that is helpful in auditing, because after 6 months if someone is coming and raising a question, you have the proof like, hey, I have audited this, this is the date when you have made some changes, and this is your old data and this is your new data. You should be having an audit of that as well. Again, like in most of the legal cases, you might need this information. That's the thing, like it is very much important. Make sure your logs are immutable, like valve write ahead logging. Your logs are immutable. Once it is written, it is written. It is an append only mode. No one should be able to go ahead and change that logs. And finally, keep your audit log separately. As I mentioned, keep your audit log separately from a normal log. So this is all about the NFRs that I wanted to discuss. So with this final video, I am terminating this series of NFR. If you feel like I have added something valuable, please do consider liking, commenting, subscribing and sharing this particular video, and subscribing this channel. Thanks.